Welcome back. Welcome back. We are done with the two electrodes, two electrolytic cells, where we are using inactive electrodes. Those are carbon electrodes or graphite. Now we are coming to the two electrolytic cells where we are using active electrodes. In these ones, where active electrodes will be used. Electrodes, remember these electrodes, why do we call them active? It's because they will either gain mass or loses mass, to undergo decrease in mass. That's why we call them active electrodes. These electrolytic cells include, which is number 3, purification of copper. Purification of copper. And the other one is number 4, which is electroplating. Electroplating. Now, just few information about electroplating. We say this happens when we cover one metal with another. So this normally is done when we are you might be doing this for decoration, to improve appearance in that case, or you might be doing this to make business, make profit out of that exercise you want to sell, or you might be preventing the other metal from corrosion. You might be preventing oxidation here. So which means that now when you cover one metal with another, normally you have to use a metal that is less corrosive than covering the one that is corrosive, like covering iron with silver. We know silver does not easily undergo oxidation. Or in terms of decoration, we are covering a cheaper metal with a metal that will be very expensive, like you are covering iron with gold. That's also now. The cells are in this way. We have got 2 electrodes. In this case, normally you don't need to be given the power. In this case, the polarity of the electrodes, because we know that if it's the purification of copper, you will be using copper electrodes in both cases. One will be pure copper. That's where the reduction is taking place. That's the cathode. And then the one is impure copper. Impure copper. Then that's where oxidation will be taking place. Therefore, this side is the anode side. The electrolyte is needed. We are going to use any copper electrolyte. In this case, we can use copper chloride or copper nitrate. In the case of electroplating, we don't need the polarity of this of the electrodes. We know that one electrode will be the one that is oxidized, and then where there is a layering or covering of the ring or anything else, then that's where reduction will be taking place. This will be the cathode part. That's where there will be the layering This side is the anode part. That's where now will be oxidation will be taking place. That's where there will be a decrease in mass. Decrease in mass. And also here, very simple, is that if I'm going to cover the ring with, let's say for example, silver, I know that if silver is going to be layered here on top of this metal, therefore this one must be silver. If I'm going to cover with gold, this will be gold. If I'm going to cover with chromium, this must be chromium. So it's easy in this one. Therefore electrolyte, if I'm covering with silver, it must be a silver electrolyte, preferably silver nitrate. We normally use nitrates because nitrates are very soluble in most cases at all times. And nitrates are soluble. That's why we are using nitrates in these cells. Let's talk about the reactions that will be taking place in these two cells as they are in operation. In the copper one, we said that the impure one, in the impure copper, copper will undergo oxidation. Therefore, that's where copper will be oxidized to form copper ion plus 2 electrodes, two electrons, and also we'll be having at the cathode. This happens at the anode. At the cathode, that's where we are having the pure copper. That's where we are going to be now having purified copper. Therefore, the copper ions will be gaining 2 moles of electrons and then forming copper. You can see that the reaction that is happening at the anode is reversed at the cathode. So hence in this case you will be now finding this one, which you have to note that the concentration of the electrolyte now will be just serving as a conveyor. The concentration of the electrolyte remains the same. It remains the same. Why? Because if we tap back to equilibrium, the reason will be the rate of oxidation. Rate of oxidation, if you want to be precise, of copper at the anode equals to the rate of reduction, in this case reduction of copper ions at the cathode. This one is optional, at cathode. You just want to show the examiner that you know more, then you can be explicit in this case. So that is why the concentration of the electrolyte is not used here. It will remain the same. So because when we lose 2 moles of electrons at the anode, they are gained at the cathode. So that is the most important one. Let's just pause and then we'll continue with the one of electroplating.